In this problem, 63, chapter 6, we have a cylinder which we are releasing it from rest on this slope. The angle is given for the degree. And also the friction coefficients, mu s and mu k, both of them are given. And we are releasing it from rest. And the question is, what is the acceleration of the mass g? What is this acceleration of the centroid g? And what is the friction force exerted from the ramp on this on the cylinder? The point is we don't know this cylinder is gonna slip or it's gonna just purely rotate. I mean, without any slip. Like any other friction problems, we have to assume it's not gonna slip. And if it doesn't slip, then if the angular acceleration is alpha, then and also angular velocity is omega. In the no slip condition, if you remember, for a rotating disk, velocity of the centroid is going to be r times omega, and acceleration of the centroid is going to be r times alpha. But if it does slip, then those equations are not going to be valid. So like other static problems which we are starting from rest, we have to assume there is no slip first and find the friction force and normal force and check if the friction force is less than mu s times n. If it passes that condition, it means our assumption is correct. Otherwise, we have to assume it is slipping and solve the problem again. So I'm going to start with the assumption of no slip. If there is no slip, then if I call this direction x and this direction y, then acceleration of the centroid in the x direction is going to be r times alpha. So let's start by drawing the free body diagram. We are going to have a normal force, we are going to have a friction, and also, of course, we have mg. And sum of the forces in the x direction is equal to mass times acceleration of the centroid in the x direction. In the x direction, we have mg sine of theta minus friction force is going to be equal to mass times acceleration of the centroid, which is r times alpha. Mass is given, the weight is given, mg, we know it, and friction force is unknown, and also alpha is unknown too. So we have 1, 2 unknowns here, alpha and friction force. Sum of the forces in the y direction is going to be equal to mass times acceleration of the centroid in the y direction, which is 0, because there is no movement in the y direction. And in the y direction, we have n and minus mg times cosine of theta. And from here, we're going to find n. N is going to be equal to mg cosine of theta. We had only one unknown, so we found it. And sum of the moments about the centroid is going to be equal to ig times alpha. Moment of mg about g is 0. Moment of n, because it is passing through j is not going to make any moment. Moment of f, I'm assuming clockwise direction is positive here. The moment of f about g is going to be f times r, and in the positive direction is going to be equal to I of a cylinder or disk about the centroid of it, about the axis of it, is 1/2 of m times r squared. So 1/2 of m times r squared times alpha. So if you look at this equation and this equation 1 and 3, we have only two unknowns in these two, alpha and f. So by combining 1 and 2, we are going to find friction force and also the acceleration alpha. So if you put the numbers, you're going to find alpha is equal to 27.6 radian per second square. And also the friction force is going to be equal to 1.714 pound. And also if you put the numbers here for n is going to be equal to n is going to be equal to 6.13. Now we need to check the criteria. We assume there is no slip, but the criteria for that is this: friction force that we found here must be less than or equal to mu s times n. If you put the numbers, friction force is 1.714, must be less than or equal to mu s times n. Mu s is given, mu s is 0.3, and if you multiply to the normal force, it's gonna be 1.84, and this is true, so it checks. So our assumption is correct. So whatever we found is going to be correct. The normal force, friction force, and alpha, all of them are correct.